There we go. Okay. All right, so here we go. I'm going to write log base 4, because that doesn't change, of the top. And then because I'm dividing, am I going to be adding or subtracting here? Subtracting. Log base 4, that doesn't change, of the denominator, but we changed the denominator into an exponent. Okay, now we're not finished yet. Okay, first of all, let's look at this first term. Okay, so hopefully you're trying this in your calculator and you're doing log of 64 divided by log of 4. I know that comes out to be a nice little 3. Okay, I'm sure. Minus, okay. Now, when you are expanding logs, you want to take your exponent and you want to make it a coefficient. Remember this last little property here? Whatever the exponent is going to go out in front as a coefficient when it comes to a log. So I'm going to take this exponent and put it right here. 1/2 log base 4 of x plus 8. And then I'm done. That's completely simplified. Okay. Sound good? Okay, let's see if we can do the next one. Okay, we got a couple of things happening here. I notice I have an exponent, so eventually 7 is going to become the coefficient to somebody. And then I also notice I have 2 items that are multiplied. So I'm going to end up having 2 logs that are added. So I'm going to start with log base b x to the 7th. I'll fix him later. That's the first little piece. And I'm going to add him to log base b of y. Is everybody okay with that so far? And that's just because I had 2 items here multiplied. Okay. And now I'm going to move the 7 to the front. So I'm going to end up with 7 log base b of x plus log base b of y. That's my final answer. Your direction said to expand. So all you had to do was make it as big as possible. Okay. Sound good? Okay. All right. This is the hardest one I could find and think of. I thought I'll just throw everything at you I can possibly think of on the next page. And then we're going to try condensing. Figure if you can get through letter F, you're good to go. Everybody okay on this page? Okay. All right, here we go. Look at this bad boy. Okay, so I got all kinds of things happening here. I have multiplication in the top with a radical and then an exponent of 5. And then I have division and then I have an exponent of my guy in the bottom. Well, I'm not going to really worry about my exponents right now. I always do them last, but I am going to go ahead and change this square root of a. What is he actually? What could I change him to with an exponent? A to the half. Good. Okay, here we go. So let's do the top first. The top is multiplied. So I'm going to be adding 2 items in the top. So I'm going to have log base d of a to the half. We'll fix him later. Plus log base d of b to the 5th. We'll fix him later. Okay, now you can, my math lab leaves it just like that and then goes on to subtract the denominator. I was always taught whatever is in the numerator, if it's more than one term, goes in parentheses. So you're going to see me put it in parentheses a lot. My math lab does not do that. So it's kind of up to you. I will let you choose what you want to do, but to me, it kind of keeps it easier to manage. But okay, then I have a division. So now I'm going to switch gears and I'm going to subtract log base d, there's Maria, c squared. Okay, and there's my denominator. Okay. All right, now we're going to move all of our exponents. So I'm going to move 1/2 to the front of this guy. I'm going to move 5 to the front of this guy. And if you don't want to use parentheses, you don't have to, but I just kind of like it. Move c to the front of this guy. Log base d, c. And there's your answer. Okay. It's not that bad. It's just one little step at a time, but that would be the hardest thing you would have to do. Okay. All right. Now, we want to go the other direction for A through F below here. Now we want to condense. So let's talk about what that means. There's two important things to talk about. We're on page 13. Okay, so we're going to make everything into one log. When you're all done, I only want to see the word log one time, or the letters ln one time. Okay, also make sure your coefficient is 1. There shouldn't be any coefficients in front. They should be moved back as exponents. It should be as teeny tiny as possible. All right, here we go. So I see 2 ln's, so I know I'm going to be condensing down to 1 ln. All right, then I see 3x minus an x. Well, what does the minus mean? Division. I'm going the opposite direction now, so it means division. So the first argument is the top, and the second argument is the bottom. And if you want to put him in parentheses, remember you can. For a fraction, you don't have to. Now, since they're sitting there together as the argument, I can cancel my x's, and I get ln of 3. Okay, so that's what I was going to bring up. So Alexis said, wait a minute, I thought you made a big deal about that, right? Okay, what I was making a big deal about is this situation. This, you can't go in and cancel. You understand? This is different. There's only 1 ln, and all you're doing is messing around in here. So this one, you cannot reduce. This one, you can. Does that make sense? Okay. All right, let's try the next guy. Okay, first thing I notice here is I have coefficients. Let's just fix them right away. Where should this 3 go? On the x. So I'm going to move him over and give x an exponent of 3. Okay, and then I see a coefficient of 2. I'm going to move him over, give the y an exponent of 2. Okay, now I'm ready. I'm going to combine these 2 log base b's into 1 log base b. Okay, and then I notice a plus. So what's going to happen in my argument? Division or multiplication? Multiplication. So I'm going to have x cubed times y squared. And you're done. Okay, now if you want to, you can put this in parentheses, but you don't have to. That's just your decision, but you're all done. Okay. All right, let's try it again. Now, we're not going to worry about, can I reduce these? You know, I don't worry about putting them in your calculator and seeing if you can come up with something until the very end. If your directions say condense, that's the goal. And then you can worry about it in the end. So I don't see any coefficients. So I'm going to go ahead and write log base 4. Okay. All right. I'm minus. So I'm going to be dividing. All right. My numerator is 24. My denominator 6. Can I reduce now? Sure, you can reduce now. So log base 4 of 4. What do we know about this situation? What does this turn into? He's just plain old 1, because remember, if these are the same, we go to 1. All right. Does that sound good? Okay. All right. Now, one thing I want to point out to you that students get weird on me. When they have this situation, they want to make the base something different. They want to make the base an 8, or they want to make the base a 0, or they want to do something to the base. Your log base stays the same, whether you're expanding or condensing. That never, ever changes. All you're doing is messing with the arguments. That's it. Okay. All right, here we go. Okay, we got another one. I see coefficients. That would be the first thing I would fix. So this coefficient of 4 is going to be the exponent on that parenthesis. And the coefficient of 8 is going to be the coefficient on x. I mean, the exponent on x. Okay, now I'm ready. So I have ln. All right, I notice I have a minus between the two, which means I'm going to have a fraction. The first argument is the top. You can put him in parentheses. You don't, oh yeah, we need to because he has a 4. All right. And then my denominator is x to the 8. And there's my answer. Okay. One thing I should point out to you is that if you look through A and F, A through F, I'm able to condense because all the bases are the same every single time. If this had been base 4 and this had been base 3, I can't do that. I can't condense. And if one of them is different, you can't expand. They have to have exactly the same bases. Does that make sense? Exactly the same bases. That's going to come up in our next section. Okay, look at here. Yeah. All right. So first of all, I see a coefficient. So I'm going to get rid of that and I'm going to move 1/7 to the exponent on x. Okay, we'll come back to him in a minute. Alexis already said it, but we'll come back. I'm going to move 4 to the exponent on y. Okay, and I'm going to move 6 to the exponent on z. E is the hardest one you would ever have to do. Okay. All right, here we go. So I see parentheses that are added, and then I see a minus for the guy in the back. This is that situation like we had up here, where the pluses in parentheses are the numerator, and the minus is the denominator. That's what's happening here. So I'm going to have log. He's a common log. I don't see a base, so we just know his base is 10. Okay, this minus tells me I'm going to have a fraction. And then the numerator is going to be these two guys multiplied together. So I'm going to have x to the 1/7 times y to the 4th. And the denominator is going to be z to the 6th. Now we're not done. Is everybody okay with that so far? We knew this was our numerator because it was what was before the minus. Okay, why aren't we done? What is the other thing? What's the one thing that's kind of weird that we could do something with? This little fraction, this exponent being a fraction. This means this is really a root, and we need to change him back to a root. So if x to the 1/2 is the square root of x, yeah, so 1/7 is going to be the 7th root of x. So all that means is you're going to have a little 7 on your index. Whoops. And there it is. That's the most complicated one I can think of for condensing. Is that okay with everybody? Okay. And so the reason is that we did the radicals because he was a fraction. And so 1/7 would be the 7th root. If you have a fraction, it's a radical. Yep. Okay, here we go on this guy. He's easy. I don't even know why he's on here, but anyway. Okay, so I don't have any coefficients, so there's no exponents, but I see a minus. So I'm going to have a division. I forgot to write log. Okay, who's in my numerator? X plus 1. Who's in the denominator? 5x. Ta-da. Okay, easy peasy. All right. Everybody okay on that page? All right, well, we're not going to worry about this little graph guy down here because you do not have to do that. They took it off of my math lab since last year, so we get to skip him. All right, and really this one's not exactly on my math lab, but I want to practice it because there is one that's kind of like this. And so I just want to make sure we can do this. So if you have your calculators, get them out. If you only have your phone, get it out. Whatever you normally do your stuff on, let's just make sure we can do this. Okay, so here's the problem. And the directions say to use a calculator to evaluate the expression, so just find the answer, round to 4 decimal places. So if you have this fancy schmancy calculator that you can use the change of base in, that's fantastic. If you don't, we're going to have to do this the other way. So remember, we're going to take regular log of 56, that's our argument, divided by regular log of pi, because that's our base. And that's going to give us the answer. So I'm going to try it in my little calculator here so we can see what I'm doing. Now remember, in most of these little calculators, you have to hit the number first. So I'm going to do 56 log, yeah, divided by, now you got to find pi. Hold on, I looked for this last night. I don't ever use this little thing. Left side. Oh, he's right. I was looking for him to be second or something, and he's right in front of me. Okay. Now I'm going to do pi log and then hit enter. Your final answer should be this. Make sure you guys can get that. Let's do it again. If you want to see me do it again on the little, here's what I did. 56 log divided by pi log enter. Okay, now let me do it on the big guy so we can see it. It's a little different. Okay, all right, big guy, here we go. Okay, whatever works on your calculator. Okay, well, you have a big one, so yours is different. Okay, so we're going to do log 56 on the big one divided by log pi, which is going to be the second little caret there. And there we get it. Okay, so it's always a little easier on the big guy. So that's how we come up with it. Everybody get their answer? Good? Okay. All right, let's then talk about some equations. This is our last section. Huh? We're going to solve them. We're going to solve exponential equations first. Back to exponentials for those of y'all that hated 4-1, we have come back. And then we're also going to solve log equations. Okay, so we're going to solve both. With each one, there are two ways to do it, depending on what your problem is. So let's talk about it first. First thing we're going to talk about are exponentials. So notice the whole page here has variables in the exponents. So we got to get those out. All right. So here are your steps. You're going to isolate your exponential term. Get that term all by itself on there. That's basic math. Whatever funky term you have, get it by itself. Okay. Your next problem is you got to get that variable out of there. Well, how are you going to do that? Okay. If possible, the easiest way to do it is method 1. It's to make both sides of your equation have the same base. Now that doesn't always work, but if you can do it, it makes your life a lot easier. Then you would set your exponents equal and solve. Okay, if that's not possible, then we have to go a little bit more complicated. We're going to take either the natural log or the common log of both sides. And then you're going to have two answers, one in terms of log, and then one that you put in the calculator that's a decimal. Okay, so this first whole page is going to be method 1. We're going to try it, and we'll talk about why it is. All right, here we go. So if this is my equation, my goal is to get this x out of the exponent. Okay, so what this tells me is to isolate my term. Well, he's already isolated. Okay, now I got to get him out. Method 1 tells me if I can make the base on each side the same, my life is going to be easier. So 2 really can't turn into anything. 2 is so small, it can't really turn into anything. But could I turn 8 into a 2 with an exponent? Sure. 2 to the second is 4, but 2 to the third is 8, right? So I can rewrite the left and I can rewrite the right because 2 to the third is 8. So I just replaced it. So this is method 1. What we did is we thought really long and hard about how to make each side have the same base. See what we did there? Okay. So if that's the case, your bases cancel and your exponents come down and we set them equal and then we solve it like a normal little equation. And that's it. Yeah, it's not too bad. So in this case, we're going to add 1 to each side. We get 4x equals 4. Divide each side by 4. X equals 1. Good. So we found a way to get each base the same. Then we cancel them and we set the exponents equal. Okay, we set our exponents equal. I'm writing that because y'all are going to get home and go, what in the world? So that's what you did. Okay, now it's not always that simple to make our exponents equal, but we're smart. We can do this. Let's think of every possible situation. Okay, let's look at this next one here. All right, so I know it's kind of hard to see, but this exponent on 8 is the whole fraction. All right, and then on the other side, I have an 8, but he's in a radical. What could I do to that right side to change him into an exponent? Yeah, okay, so I'm going to write over the left. And then what I want is an 8 on the right with an exponent. So what kind of exponent is he going to get? 1/2, because he was under a radical. If you're going to turn the radical into a fractional exponent. They're the same thing. Yep. Okay. Everybody good on that? Okay, we're crossing out our 8s. We are setting our exponents equal. Okay. All right, we have a common denominator here. If I multiply both sides by 2, what happens? The denominators go away. And then I just have to add 9. And I get x is 10. Okay, not too bad. All right, now we're going to get trickier. Okay, let's think about this for number C. Okay. All right, so we have clear little exponents. We have bases of 9 and 27. All right, well, normally what we've seen is that we would take the bigger exponent and turn it into, the bigger base and turn it into the smaller base. Like we turned 8 into 2 cubed. So you would think, well, maybe we turn 27 into 9. But does that work? No, because 9 to the first is 9. No, what's 9 squared? 81. That's not going to work. But they do have something in common. What if they have in common? We can totally do a 3, because let's think about this. 9 is 3 to the what exponent? 2. What's 27? 3 to the third. So I know we still have to deal with these exponents, so we're going to get there in a minute. But what we did is now, because we couldn't make the bases exactly one or the other, we knew we could make them both a base of 3. So 9 is 3 squared and 27 is 3 cubed. Does that make sense? Now, we still have to deal with these exponents out here. So what we do is we put them in parentheses next to the exponent that's already there. And that's how we handle that situation. So that's pretty wild, but that will help you so much. Okay. Everybody okay with that? Okay, now we're going to cancel our bases and we're going to rewrite our exponents and we're going to distribute and solve. So we're going to get 2x plus 8 equals 3x minus 6. Okay, and then we just clean it up. I'm going to subtract my 2x because I like to have a positive variable. But whoever you move, you should end up with x equals 14. And there you go. Okay. See what we did? Does that make sense? Okay, that's going to come in handy for this next dude. Okay, so here we go. For this next guy here, there's not a lot I can do for the 4. So I'm going to just rewrite that side for now and handle that. Okay. Now, what I also see here is that I don't want a root anymore. So I'm going to put 256 to the what exponent? The 1/2. Okay, good. Now stay with me here. I don't want a fraction. I want him to be on the same level as the 4. So I can rewrite him up in the numerator, up in the top. But what happens to his exponent of positive 1/2? He becomes negative 1/2. Okay, so we made a lot of progress on him. We at least got him out of the radical and we got him up normal, so he's not in a fraction. All right, now our job is to make these two guys the same. Can I turn 256 into a 4? Well, I really don't know. So that's where your calculator comes in. I know that 4 squared is 16. 4 to the third is 64. 4 to the fourth is 256. So I can really make 256 into 4 to the fourth. So this is really 4 to the fourth, but he still has that little negative 1/2 hanging around, okay? Because 256 is 4 to the fourth. It's kind of like the same thing that we did here where you're going to have an extra exponent out there. Okay. That's pretty rough stuff there. You wouldn't have that stuff on a test. Your test question would look more like A, letter A. But now we're going to cancel our base. We get 3x plus 5. What's 4 times negative 1/2? Negative 2. Okay. You're going to subtract your 5, divide your 3. I'm just going to go ahead and give you the answer. Should be a really ugly negative 7/3, which happens sometimes. Oh, no, just one of this type, but yours would be more like A. Okay. Sound good? Okay. Good. Okay. Everybody got it? Okay. Good deal. So that was method 1, right? Okay. So we were able to turn each base into the same. Okay, let's look at this situation here. All right, first thing I notice is I'm isolated, of course, 10 to the x. Okay, is there any way to turn 10 and 24 into the same base? No, there's just not. They don't have anything in common. It's not going to happen. So this is going to be method 2. That's what's going to happen here. Okay, with method 2, you're going to take the log of each side. So you have to choose. Do you want to take the common log of each side, or do you want to take the natural log of each side? Now, it really depends on the problem. This common log has a super secret base of what? 10. So if I have a 10 involved in my problem, I'm going to use this dude. What's the super secret base of ln? E. So if I have an E involved, I'm going to use that. Now, C doesn't have either involved. So that's really your choice. It depends on who your math teacher was. When I was growing up, I was always taught if you can use either one, take the ln. I don't know why. That's what my teacher always taught me. My daughter, when she was in dual enrollment pre-calc, they had to do stuff like this. Her teacher at IRSC told her to always take the common log. It's the same thing. So it really doesn't matter. My math lab will take either one, but because I grew up being taught to take natural log, that's what I'm going to teach you. Okay, but it really doesn't matter. Now in A, we're going to take the common log because we have a 10 involved. Okay. All right. So I'm going to take the common log of each side. Okay. That's only because I can't make the bases the same. Then look what happens. Remember, my super secret base is 10. So what happens over here on this left side? If this base and this base are the same, what's on the left? Just plain old x. Now, I don't have anything cool to do over here. He's just going to be log of 24. And that's all I can do to him. So that's my answer. When you use method 2, you're always going to end up with a log or an ln in your answer. Okay, this is method 2. Okay, so you're going to have 2 answers though. All right, so this is your first answer. Your second answer is the calculator answer, and this wants 2 decimal places. So this is just plain old common log, so I don't have to change my base or anything. I'm going to do 24 log of 24, I get 1.38. There we go. Okay. All right, 2 answers from method 2, 2 answers. Okay. All right, let's try this guy. All right, he is the first time we've seen something where it's not isolated. Does everybody see that our exponential is not isolated here? We need to divide our 7. We need to get e to the x by itself. So it's going to be e to the x equals 4. Okay. Now, because there's no way I can make e and 4 be the same base, so I have to use method 2. And by the way, method 2 always works. So if you don't ever want to do method 1 ever again in your life, you don't have to. Okay, method 2 always works. What you got? Huh? Is that not right? No. I tell you what, it'd be really nice if you had a math teacher that knew math. Sorry about that. Okay, so he doesn't reduce, so we're just going to leave him. I thought I was really doing something. Okay, anywho, all right, so do we want to take the common log or the natural log of this guy? Natural log, right? Natural log, because he's the one with the super secret base of e. So if I take my, let me scooch him over. Natural log of each side, okay? I know I have a secret base of e, so what's my left side going to be? X. And my right side, there's nothing I can do with that. They don't want you to expand it or do anything weird. You're done. Okay. Now let's try putting him in the calculator because you're going to need 2 answers. So you're going to take 24 divided by 7, natural log, or however your calculator likes to do it, 1.23. Huh? ln. Okay, and there we go. You got 2 answers. All right. I really don't have time to do both of these, so I'm trying to figure out which one I think is probably the worst. I think C. Let's do C, and we're going to leave off D. But D is on, Blackboard under content, so it's on here. I just want to be able to get to the log equations before we run out of time. Okay. So here we go. I'm isolated, but look at this. This is the first time we've seen each side have an exponential, and I can't turn 2 and 6 into the same base. Seems like I ought to be able to, but I can't. So I need to either take the log or the ln of each side. So again, this is where it's kind of depends on your teacher. I'm going to take the ln of both sides because that's what I've always been told to do. So I'm going to take the ln of this dude, and the ln of him, and there we go. Okay. Now remember, the whole point of this is to get your x out of the exponent. You want your x down on the regular level. So do we know any certain type of property or situation where I could take this exponent and put it down somewhere else? You just learned it. Okay, so remember, we can take exponents and we can move them in front, right? As coefficients if we've taken the log. Sure, yeah, sure. Okay, so now I'm going to put them in parentheses since there's more than one term. There we go. All I did was scoot them over there in the front. Okay. Now this is when you're really kind of getting the weeds on math. So here we go. What we're going to do is distribute. Now, if you don't like to because what we're going to do is distribute the ln through there. So if you want to rewrite this with the ln in the front, you can. It's not really done, but that would help you distribute. You can, but basically what you're doing is just you're distributing each one. So you're going to get 2x ln of 2 plus 3 ln of 2 equals x ln of 6 plus 1, or just plain ln of 6. Okay, so you're just distributing it through there. Okay, the goal here is to get the x's together. You're trying to get the x's all by themselves. Everybody okay so far? All right. Then notice I have two x's. They're right here. Sure would be great if they were on the same side of the equation and everybody else was on the other. So we're just going to rearrange terms now. I'm going to leave this guy where he is, and I want this term to come over to this side. So I'm just going to subtract him. I'm just kind of doing this all in one step because I'm out of room. And that leaves me with ln of 6 over here, and I'm going to subtract the other term over to here. I know that I did that in all one giant step. If you want to separate it into 2 or 3, you can. But what I did is I put both x terms on one side, and I moved the other 2 terms to the other side. Okay, I just scooted them over. Everybody okay with that? All right. That was the hardest part. Now, I want these x's by themselves. So if both of them have an x, I'm going to pull it out, kind of like a GCF. And I'm going to be left with 2 ln 2 minus ln of 6. And then everybody on the right is the same. I just isolated my x and pulled them out. This is not a test question, so don't panic. This is just in my math lab. And now I want x alone, so now I'm going to divide both sides by this other stuff. And your final answer is that guy, which is crazy looking, right? Okay, so we put the exponents out in the front. We distributed them. We moved the x terms to one side and the other terms on the other. We pulled out the x like a GCF. And then we divided both sides by what was left after we had pulled out the x. This is a super hard problem, but you would not have this on your test. It won't even be a bonus. It won't be anything except my math lab. Okay. All right. Now, the even trickier part is trying to get this beast into your teeny tiny calculator. And when that happens, and I'm just going to kind of tell you what it is, you got to do each little piece separately at a time. You should come up with 0.71. Oh, thank you, dear. I'm really off my game today. Sorry. That'll be a 6. Yeah. Good. Shalandra. Oh, from here and here? Oh, okay, good question. They would if they weren't being added or subtracted. But because you have addition and subtraction, you can't cancel anybody. You just have to leave it alone. Yep. And just have the big monster there. So in your little calculators, you would take ln of 6, you could write that down, minus 3 times ln of 2, write that down, subtract them, write that down, you know, and you have to just do each little piece at a time unless you have the big giant calculator to come up with this. So it's kind of, it's a lot. It's a lot. That's why you're not tested on it. It's way above the scope of this class, but they do put it on my math lab. Okay. Is that all right? Okay. All right. Let's talk about log equations because they are so much easier. Okay. You already know how to solve log equations. All right. So here we go. First thing we want to do is isolate our log, coefficient of 1. Then, if you only have one log, put it in exponential form and solve it. You guys already did that. We did examples like that. If you have 2 logs, you get to cancel them out and make your arguments equal and solve. Here's the one little sticky requirement. Your arguments have to be positive with logs. So just because you find an answer doesn't mean it's a valid answer. You have to take that answer and look and see what it does to the argument. If it makes the argument negative, you can't use it. You would put no solution. If it makes your argument positive, you get to keep it. Okay, so let's try here. Our log has been isolated and there's only one log. So we're going to make it exponential. Okay, here's our base of 2. We're going to raise it to the -2 power. And it's going to equal x minus 3. Okay, remember that? How we turn it into an exponential? Start with the base, raise it to the right, equals the argument. And now we're just going to solve it. So this is really 1/2 to the second, which is really 1/4. Okay. And now if we add 3 to both sides, okay, you're going to end up with 13/4 as your answer. Okay, so all I did was take 1/4 plus 3. You can always change your little 3 into a denominator of 12, well, 4, I guess. Okay, and you get 13/4. Now, remember, we then need to check that. So if I put that into my argument, 13/4 minus 3, it's positive. So since it's positive, I get to keep it. You have to check it by putting it back into your argument. And if your argument is still positive after you put this back in, you're good to go. But you have to check it, okay? All right, let's try another one. We're not going to do all of these because they're just not that bad. Let's do, okay, let's do C. All right, so I notice I only have one log. He happens to be the natural log, but he is not isolated in any way. So let's isolate him. We're going to subtract 4 and get 6 ln of x equals 54. We're going to divide both sides by 6 and we get ln of x equals 9. Okay. Everybody good there so far? Okay. All right. Now, because there's one log, we're going to put it in exponential form. So what's my little base for him? E. So I'm going to start with E. I'm going to raise it to the 9th, and it's going to equal x. And you get to leave it just like that. Okay. Now, it doesn't hurt for you to then check and see, is your argument positive? In this case, our argument's just x. So e to the 9th is a positive number. So yes, that's fine. We get to keep it. Okay. All right. Let's try D. Okay. All right. So what's my base for this guy? Because he's already isolated. 10. Okay. I'm going to have 10 to the 0 equals x plus 12. That's my argument. What's 10 to the 0? 1. You can put that in your calculator if you're not sure, if you don't remember. Okay, I'm going to subtract 12 from both sides, and I get -11. Okay, now just because he's negative doesn't mean that he can't be our answer. We just have to check it inside our argument. So if I put in -11 for x, our argument is still positive. So we get to keep it. If the argument had become negative, then that's when we would have to write no solution. Okay. All right, let's skip E because we have another problem really similar to it on the next page. The only one I'm going to do on the next page is, let's see. Let's do H. Let's do H. Okay, just because we're kind of running out of time here. All right. So with this page, it looks like, oh, she's moved on to that second type where there's more than one log. Unfortunately, no. The only time you can use that second type where you have more than one log on each side is when you just have log equals log. Okay, so let's see. Well, actually I can. Okay, let me go back up to F. My bad. Okay, let's go up to F real quick. Okay, so, and then we'll come down to H. Okay, so in this case here, I've got this log on this side, but I have 2 logs on this side. I have 3, and I don't want 3. I want 1 log equals 1 log. So I'm going to condense these and put them together. So I'm going to have log of x plus 4 on the left. And on the right, I'm going to have log. And then these 2 are added. So what's going to happen in their argument? They'll be multiplied. So I'm going to have x times 4 or 4x. Okay, so now I do have log equals log. So my logs are going to cancel. And all I have to do is set my arguments equal and solve. So I'm going to subtract x from each side. 4 equals 3x. I'm going to divide by 3. And x equals 4/3. And if I check that in each argument, all the arguments are positive. So I'm good to go. Okay. All right, so same thing here. I would just combine those together. All right, we're going to skip G and go down to H, but I would just want to show you that we would combine these together just like we did up here, and then your LNs would cancel. Let's look at what happens at H though. Okay, this will be our last one that we're going to do. So you would think, oh, this is easy. I'm just going to maybe move 1 log over to here, and then I have log equals log. But the problem with that is this stupid 4 is sticking out of the way. If I add 1 log to the other side, I still don't have log equals log. I have log equals 4 plus log, which is not what we want. So I'm going to condense these. I get log base 2. My numerator is x plus 7. My denominator is x minus 8. And that equals 4. Okay, so I really just have 1. And what do I do if I have 1 log? 2 to the 4th equals this argument. Okay, so 2 to the 4th is going to be 16. I want to get rid of my fraction, so I'm going to multiply both sides by x minus 8. That's my denominator, and that's going to make that denominator go away. And I've got 16 times x minus 8 equals x plus 7. I'm going to distribute. And then I'm just going to solve for x. So if I subtract x from both sides, and I add 128 to both sides, I get 15x equals 135. Divide both sides by 15, and I get a 9. And that does leave both arguments positive. So that's going to be my final answer. Okay, so I know we didn't get to a lot of these, but just kind of, if you need to, look them up on content because they're all here. Bless you. And then we're not going to do 4.5. So that takes us through to our test review tomorrow. Okay, but text me or email me if you have any problems. Okay. Right.
I saw that and I was like, oh my God, this is literally
Okay. Yeah. All right. No problem. I will do that. And then I'll see you next week. No, I'll see you tomorrow. Right? Okay. No problem. Okay. Caitlin, Lauren, Ray. okay, while we're packing up, what do we think about, what should we do? Do y'all want to meet after powder puff practice? Do you just want to look at the video? What do you want to,
I got it, powder puff?
No,
It's the same days as like guys.
but it ends at 4:30?
It ends at 4:30.
You want to come at 4:45-ish?
I don't care.
Is that okay, maybe? Okay, why don't we do that on,
Wednesday.
yeah, let me look either Tuesday or Wednesday. Let me look and see what's better for me, but, one of those days for sure. That's okay. Okay, all right, sounds good. We'll do that. Okay, bye. Bye. Hey, how are you, long lost stranger?
I've been not feeling good either.
I know, and then you still gotta do test 3. I don't know what to do about that.
Yeah, I know, I said I can do it tomorrow, but then you just said test review tomorrow, so I was like, oh no, I can't do it tomorrow. Or I can just stay after, because I don't have class for my, my next college class, I was gonna just, test review, then I can stay after and do it.
Okay.
Because I was gonna come the other day, but I haven't been feeling good. I had to go to my doctor because like the birth control that I have is just messing me up really bad.
Yeah.
So like I just had like really sharp pains in my stomach. And like when I woke up in the middle of the night, I felt like someone was stabbing me.
What did he say? Did he get fixed?
No, I haven't went yet. I have to make an appointment because they take, if you walk in, I'll be there. When I did make an appointment, I was there for an hour. I went to Florida Community Hospital.
Okay, yeah, they take forever.
So then I had got there and I had an appointment. It took forever. So I know if I walk in, it's gonna take even longer.
Yeah.
And it's just like, I mean, I've been feeling better like lately, but and then now like the baby, she has like a cold. I think it's like you can hear her. Yeah, you can hear her like when she's in the middle of the night, like when we make her bottle, you can hear her go. Yeah, and then she's in a little habit right now where she like, if she gets excited and she's like, we either have her in her packing plate or her crib. When she gets excited, she'll go throw herself back. And in her packing plate, she had a little xylophone thing. And she hit herself back and hit her head. And like you can hear it on the packing plate, but there's like kind of like a soft part, but it still sounds. And this morning, I was getting her out of her crib because she woke up and I went to go grab her. She went and threw herself back and hit herself between the bars. And I was like, oh my gosh. And then she said it like she was like, she didn't know what to react. And I was like, oh my gosh. And like she won't get out of it. Like she won't get out of that habit. So I was just like, and then her dad was so tired yesterday. Like when I got home, he was sleeping. So I was like, everybody's just not feeling good.
Oh my gosh, I can only stay though till like 10:20 today.
That's okay. I know. I don't know when this.
I wish I could stay longer with you, but I just.
I know she had extended like one of the assignments, but my Blackboard hasn't been working. Like I told like one of my professors that have a problem with the most is Mr. Moore. Right? When I think it's only like with your classes, all our stuff is on my math class, so it doesn't really pop up on Blackboard.
Right.
But like with his, like it used to be like what's coming up due.
Yeah.
Or like what's past due or what's due like tonight. It doesn't do that anymore for me. So I miss like I mean, he lets me like do it.
That's good.
But I'll be like, because he'll be like, no, we talking about a quiz. And I was like, we had a quiz. And then I was like, it doesn't pop up on my Blackboard every time I look. And then he's like, were you in a different class period? I was like, no, I wasn't. I was like, I just don't know why I'm doing it. So he's like, and the same thing that's happening with my projects, it's not letting me turn in my projects to him. And those are test grades. So I was like, I think I'm supposed to go tomorrow during school